morning students, welcome to Lakshya Academy YouTube channel. In this video I explain some numericals on half wave rectifier and full wave rectifier. Let us start. First problem, the applied input AC power to a half wave rectifier is 100 watt. The DC output power obtained is 40 watt. What is the rectification efficiency? What happens to remaining 60 watts? And that is the question. So half wave rectifier, input power is given as 100 watt, input AC power is 100 watt, and output power is 40 watt. This is output power 40 watt. Rectification efficiency. The efficiency of half wave rectifier is given by DC output power divided by AC input power. Efficiency of half wave rectifier, DC output power by AC input power. The ratio of output power to the input power is nothing but efficiency. So which is 40 watt divided by 100 watt, which is 0.4. The percentage of efficiency is 0.4 into 100, which is 40%. So the rectification efficiency, the percentage efficiency of half wave rectifier is 40%. Next, focus on the second question. What happens to remaining 60 watts? What happens to remaining 60 watts? The input power is 100 watt. The output power is 40 watt. So in the second question we have to answer that what about 60 watt, remaining 60 watt. Yeah, 40% efficiency of rectification does not mean that 60% of power is lost in the rectifier circuit. It's not mean that the 60% power lost in the rectifier circuit, but the diode consumes a little power due to its small internal resistance. So out of that 100 watt AC power, 50 watt in positive half cycles and 50 watt in negative half cycles. So in the case of half wave rectifier, the 50 watts in the negative half cycles are not supplied at all. Only 50 watts in the positive half cycles are converted into 40 watts. Okay, in the case of half wave rectifier, the 50 watts in the positive half cycles are converted into 40 watts only, and 50 watt in the negative half cycles are not supplied at all. So power efficiency equal to, note down that power efficiency power efficiency equal to 40 divided by 50 into 100, that equal to 80%. This is power efficiency, not the efficiency of half wave rectifier. In only few cases they ask the power efficiency. Most of the cases they ask efficiency of half wave rectifier only. So although 100 watts of AC power was supplied, the half wave rectifier accepted only 50 watts and converted it into 40 watts DC power. So this half wave rectifier is appropriate to say that efficiency of rectification is 40% and not 80%, which is power efficiency. Efficiency is power efficiency and not the efficiency of half wave rectifier. The efficiency of half wave rectifier is 40%. Efficiency of half wave rectifier is different than that of power efficiency. Next, move on to second question. In a half wave rectifier, output is taken across a 90 ohm load resistor. If the resistance of diode in forward biased condition is 10 ohm, the efficiency of rectification of AC power into DC power is. In a half wave rectifier, output is taken across a 90 ohm load resistor. If the resistance of diode in forward biased condition is 10 ohm, the efficiency of rectification of AC power into DC power is. This is the case of half wave rectifier, and load resistance is given as 90 ohm. RL equal to 90 ohm. Load resistance is given, and resistance of the diode in forward biased condition is RF, denoted by RF, equal to 10 ohm. We know that efficiency of half wave rectifier is eta equal to 0.406 times RL divided by RF plus RL. Efficiency of half wave rectifier eta equal to 0.406 into RL by RL plus RF. So eta equal to 0.406 into 90 by 10 plus 90, which is 36.54 by 100, 0.3654. This is the efficiency of half wave rectifier. Therefore, percentage of efficiency of half wave rectifier is actually eta equal to 0.406 into RL by RL plus RF into 100. So 0.3654 into 100, 36.54%. In the given problem, the efficiency of half wave rectifier is 36.54%. This is the second problem. Next, third question. In a full wave rectifier, output is taken across a load resistor of 800 ohm. If the resistance of diode in forward biased condition is 200 ohm, the efficiency of rectification of AC power into DC power is. In a full wave rectifier, output is taken across a load resistor of 800 ohm. If the resistance of diode in forward biased condition is 200 ohm, the efficiency of rectification of AC power into DC power is. Okay, the load resistance is given as 800 ohm, RL equal to 800 ohm. The resistance of diode in forward biased condition is 200 ohm. Efficiency of full wave rectifier is eta equal to 0.812 into RL divided by RL plus RF. Efficiency of full wave rectifier eta equal to 0.812 into RL by RF plus RL, which is 0.812 into 800 by 200 plus 800, just substituting the values of RL plus RF. Which is by simplifying we got 649.6 divided by 1000, 0.6496. This is the efficiency of a full wave rectifier. So if we want percentage efficiency of full wave rectifier, eta equal to 0.812 into RL by RL plus RF into 100, that is next problem. If input frequency is 50 Hz, then ripple frequency of center tapped full wave rectifier will be equal to, and this is important one. Input frequency is 50 Hz, then the ripple frequency of center tapped full wave rectifier will be equal to. Okay, so this is nothing but a full wave rectifier. In the output of center tapped rectifier, one half cycle is repeated, hence frequency will twice as that of input frequency. In the problem, the input frequency is given as 50 Hz. So in the case of center tapped full wave rectifier, both the positive cycles and negative cycles we got as output. Okay, so the output frequency, the ripple frequency is twice that of the input frequency, that is 100 Hz. So option A is correct. Next, fifth one. If the input frequency is 50 Hz, then ripple frequency of half wave rectifier will be equal to. Input frequency is 50 Hz, then the ripple frequency of half wave rectifier will be equal to. In the case of half wave rectifier, only positive pulses converted as output, the negative pulses do not. The ripple frequency of output and input is the same in the case of half wave rectifier, since one half cycle of input is passed and the other half cycle is blocked. So the efficiency of half wave rectifier, the ripple frequency of half wave rectifier is same as that of the input frequency. So the ripple frequency is 50 Hz. So option B is correct. These are the two problems. Yeah, next, sixth one. In the circuit given below, the value of current is. These type of model problems are important. a circuit is given, PN junction diode is given. This is the P side of the PN junction diode and this is the N side of the PN junction diode. So, the P side is connected to a voltage of plus 4 volts and the N side is connected to a voltage of plus 1 volts. Compare these two, plus 4 and plus 1 volts. Plus 4 and plus 1 volts. So, this is higher potential than plus 1 volts. So, P side is connected to higher potential side and N side is connected to lower potential side. It is nothing but the PN junction diode is in forward biased condition. So, if the diode is ideal diode in forward biased condition, it offers a very less resistance. If it is ideal, 0 resistance. So, in the given problem, the diode is in forward biased condition. So, it conducts. Okay. So, current flow is possible in this case. So, according to Ohm's law, current passing through this circuit is net EMF by net resistance. Here the diode offers 0 resistance and a 300 ohm resistance is given in the problem. So, according to Ohm's law, I equal to net EMF by net resistance. Net EMF is potential difference 4 volt minus 1 volt divided by 300. So, 3 by 300, 1 by 100, 10 power minus 2 ampere. 10 power minus 2 ampere. Next question. What is the current in the circuit shown in the diagram? This is the previous question only. So, in this problem, a PN junction diode is given. The P side is connected to minus 4 volts and N side is connected to minus 1 volt. So, minus 4 is lower potential than that of minus 1 volt. So, the P-type semiconductor is connected to lower potential and N-type semiconductor is connected to higher potential. So, the diode is in reverse bias condition. So, if the diode is ideal diode in reverse bias condition, it offers infinity resistance. So, if it offers infinity resistance, there is no current flows in this circuit. So, the current passing through the circuit is 0 ampere. Okay, thank you.